Hey guys, go ahead and pause this video and copy these notes down in your notebook. By the way, the bell's going to ring in a minute. Just ignore it. Obviously, you're not getting out of class early just because the bell on the video rings. All right, just a short review. I'm going to move the notebook. Just a short review. Ionic bond means giving away. It is the reason that when we had lithium with 1 and chlorine with 7, we would draw the arrow and put that electron there because lithium no longer has that electron, and you know that because it now has a charge on it. And chlorine now does because it has a charge on it. So ionic bonding means giving away or accepting electrons. This happens with metals and nonmetals. And the way you should remember that is the fact that this happens all over the periodic table. The metals are over on the left-hand side, the nonmetals are over on the right. So there really isn't a part other than, we don't really use the lanthanides and anthonides, the bottom two, or the noble gases. We don't normally use those, but everything else we use. Covalent bonding is going to happen between two nonmetals. And all types of bonding only involve the valence electrons. It doesn't involve the inside electrons, just the outside. So valence electrons are shared during covalent bonding, and that happens between two nonmetals, and they do this to follow the octet rule. Remember, the octet rule says that atoms want full or 8 valence electron shells. And if you remember, our nonmetals over on our right-hand side, they always want to accept electrons. So they're not going to really be up for giving them away. So like our oxygen always wants 2 electrons, and it has 6. The reason it's going to share them is because it doesn't want to give them away. It already has 6. So the octet rule is just trying to make sure that everyone has a full or 8 valence electrons. In order to name covalent bonds, we're going to use prefixes, which I'm going to show you in a minute. And whenever we have a covalent compound, we normally call that a molecule. Now, when we name, we add a prefix to indicate the number of atoms, except whenever your first element only has 1. And during that case, you're not going to use the word mono. And we're going to do a couple of examples with that. You're going to change the ending of the second element to I, just like we did with the binary and all of the ionic compounds, unless we were using a polyatomic. So the oxide, chloride, fluoride, all of those things are still going to be used. So here are the prefixes. The prefix for 1 is mono, for 2 is di, for 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa like octopus and octagon, 9 is nona, and 10 is deca. And I believe you've done some of this in geometry. Some of my kids this morning knew it. So now we're going to go ahead and go over to the example side. All right, go ahead and pause the video and copy these as well. Now I think it's easier to work from name to formula, so we're going to do this one first, and then we're going to come down and work these, and then we'll come back up and work these. The easiest way to do it is to underline the prefix. So di is our prefix here. Carbon doesn't have a prefix, but I'm just going to draw a line. And what you're going to do is underneath that line that you've drawn, go ahead and write what number that indicates. So di indicates a 2, and it being a blank indicates a 1 because it's on that first word. So you're just going to write your 2 elements, which is C and O, and then write those numbers. We don't have to write a 1 because it's understood, and then the di, you're going to put that 2 right there. So we're going to do the bottom one as well, the arsenic trichloride. If you look on your periodic table, obviously this one doesn't have a prefix. This one does. Arsenic is AS. There isn't a prefix, so it's an understood 1. Tri is 3, so it's CL3. Here we go. We're going to underline both of these prefixes, the di and the pent. Nitrogen, there's 2 for di and 5 for pent, which means there's 2 nitrogens. And oxygens, there's going to be 5 of them. And then there's tetra and deca. And phosphorus and oxide, so we're going to put a P and an O. That P, tetra, means 4. So we're going to have a 4 as our subscript. Deca means 10. So we're going to have a 10 as our subscript to that one. And you're going to see these being a lot larger because of the fact that they're covalents. We wouldn't have had a 10 with the ionics because there wasn't an oxidation number of a 10. All right, so when we go from names, you're just going to work left to right. And these are left to right on the periodic table as well. So the ones on the left are always the ones that are farther to the left than the ones on the right. So we have carbon, but there's 2. So our prefix is going to be di, carbon. The first word is always just going to say its name. The first element is just always going to say its name. And then there's a 4, which means tetra. And the last word has to have the "ide" on it, so it's going to be tetrahydride. You probably won't see a lot of the hydrogens. You'll see a lot of oxygens. Okay, so we have 2 nitrogens, which means we have di again. And then it's nitrogen. It's the first word, so it's just going to say its name, nitrogen. There's only 1 oxygen, which means because it's the second element, it has to have a prefix. So it's going to have a mon. And it being oxygen means it's not going to have 2 O's like mono-oxygen. It's just going to be monoxide, O-X-I-D-E. Here, there's only 1 sulfur. If it was the second one, it would have that mono, but since it's the first one, it doesn't have a prefix, so it's just going to be sulfur. There's 6 fluorines, and if you look on your prefixes, 6 is hexa, so it's hexa. You don't say fluorine, you say fluoride, hexafluoride. And last one, there's a carbon. There's only 1, but you're not going to say monocarbon because it's the first one, so it's just going to be carbon. There's only 1 oxygen, which means you're going to put that mono on it, so it's going to be monoxide. And carbon monoxide is the gas that's given off by our cars and by our heaters that can be deadly in large quantities. So go ahead and finish the worksheet that you should have picked up in class today.